All right, today we're going to be talking about the conservation of momentum, or the Sticky Collisions Lab, which is this guy right here. So basically what we have is we're going to have two carts, cart one, cart two. This cart is a plunger cart. So if there's a spring in there, you stick it up like that, then if you hit it, it's going to, boom, come out. It's going to hit against this wall here, which means it's going to give a force, which is now going to accelerate this guy. He's now going to move, and he's going to hit this one. They have Velcro on each other, so therefore they're going to stick. So let me just sort of give you an idea of what it's going to look like. And we have to really make sure that these carts themselves are level on the track, because if not, then you've got these additional factors which are a part of it. And the thing that gets really tricky is I need to get this guy to be right against the wall. If there's any distance to it, it's going to lose a lot of the energy and the force that you're going to be getting from that. For any of you guys that swim, it's the sort of thing that when you come up to do a flip turn, if you do a flip turn too early and you're far away from the wall, when you kick, you're not going to get much. You're going to be just sitting like a dead fish in the water. You got to be all the way to the wall. Like here, we got to be all the way to the wall. Okay, so that guy's going to be there, and you'll see that when I hit this guy, whoop, they stick together and they move on. Now, it's also important that when you do it very quickly. I don't want a lot of friction between these two because I want to get all of the energy to go into the collision itself. That's what the important thing is, to get into the collision itself. So I'm also going to set this guy at the same distance each time, and it's going to be 63 centimeters. And why 63? Because what's going to happen is it's going to hit, and this sensor is going to pick it up at 60. So we'll be able to get it from there. So just like the labs we've done before, you'll hear the clicking. That means it's getting ready to register. And now I go and I hit it, and boom, you can get that. And as I take a look at that particular one, so 0.326 seconds, and I write it in on the data table, which is there. So after we do that 3 times, then what we're going to do is we're going to do it again, but we're going to put extra mass on. So the first time we ran it, we had half a kilogram for the one cart, half a kilogram for the other cart. Now what we're doing is we're increasing the mass. So we're going to have half a kilogram here, half for the black bar, half for the cart, which means now we've got a total of 1.5 kilograms, as opposed to before when we had 1. Now think about that and think relative to, should my velocity be bigger or should my velocity be slower if I now increase the mass of the collisions that we are having? So I've got that set to the same thing. I would go and I would start this again. I would come in with my little guy here. I would hit it, boom, and you get that. I'm going to let you guys see if the velocity was greater or lesser on the data which we obtained and see if that makes sense. So on these, what we're going to be doing is we're going to know the masses of all the objects involved. We're going to know the final velocity. And so then what you're going to be determining is, what is the initial velocity when this guy comes off? Now remember, when you're doing this and you're looking at how it's going to work, think about what's the velocity of the second object beforehand. This one has a velocity. Figure out if this one does or doesn't. And then remember, for the after momentum, they're stuck together. So you've got to go and include all of those masses and think about what's happening with those. In the last condition, we're going to take the velocity which we had from one of the earlier ones for this initial velocity there. And now what we're going to do is we're going to determine the mystery mass. It's just a box of staples. So we put the box of staples on there. We have that guy here. Now, when we go and we run this, and I hit this, aha, I get my own particular values which happen to be there. Now, once again, think about what's going to happen. When you take a look at the numbers, if this velocity happens to be greater or lesser than what it was for just the simple carts or the cart with 1 bar, now you can estimate, without even doing any calculations, approximately what this is going to be. But you will actually calculate it. So that's basically the lab. You're starting out with collisions, 2 objects, half a kilogram, half a kilogram. Then we're going to go to half a kilogram, 1 kilogram. Then we're gonna go to half a kilogram, and mystery mass. In the first two cases, you're finding the initial velocity. And in the last case, you're gonna use that initial velocity that you found before to be able to determine an unknown. That's basically the lab.
Cool.